Say hello to your worst nightmare. Yesterday we talked about logistics growth. Now today we're going to continue on that, but today we're going to solve logistic growth equations. So let's talk where we have a community in this problem and the flu is spreading through the community. And this differential equation models the rate at which the flu is being spread. Now, in part A here, they give us an initial population. So they're telling us that at the beginning, 50 people have the flu. And they're saying solve for P. Now, we've done this before in the past. We've solved for P. If I write out my differential, dP dt is going to equal, and I'm going to write this as 1 over 1,000, just makes it a little bit easier. 1 over 1,000, P, 3,000 minus P. Now, we've solved differentials before in the past. The goal here, remember, is to put your p's to one side, everything else, the t's to the other side. So I'm going to go ahead and do this. If I solve for this one right here, I'm going to get 1 over, be very careful, I get p times 3,000 minus p dp equal to 1 over 1,000 dt. Remember, we call this separation of variables, where we separate the variables. And this is very easy to do. Our next step then is to just integrate this. Now, here's the problem. The right side is easy to integrate, but the left side, I have two p's, and in fact multiplied together. So I have p. If I got rid of the p, that's simple. 3,000 minus p, that just becomes natural log. Or vice versa, if I get rid of 3,000 minus p, I get natural log of p. But the problem is I have both of them. This involves one of our new integration techniques. In order to integrate this one, we have to go off to the side. We have to use partial fractions in this case. So we're going to integrate this very simply. I'm going to get 1 over p times 3,000 minus p equal to, remember this, a over p plus b, sorry I forgot my parenthesis, over 3,000 minus p. And I'm going to solve this problem right here. Multiply through by the LCD, we're going to get 1 equals a times 3,000 minus p plus b, p. Finding the zeros, our first zero is going to be p is 3,000. And if we do that, we should be pretty quickly to this one. 1 equals 3,000 times b, or b equals 1 over 3,000. My next zero, let p equal 0 from right over here. And we're going to get 1 equals 3,000 a, or a equals 1 over 3,000. So that's our partial fractions. And I can use this to rewrite my integral. This one over here, it's a over p. I remember it's a over p, so it's going to be 1 over 3,000. And the b is also going to be 1 over 3,000. So if you notice, they both have this 1 over 3,000. So I can kind of factor that out if I wanted to. And I'm going to get this a over p, so I'm going to get 1 over p plus 1 over 3,000 minus p dp. And that's going to equal the antiderivative 1 over 1,000 dt. Remember, the 1 over 3,000 I got from my a and my b. I could just plug them in, but then I'm just going to factor it out anyways. When I now integrate, be very careful. We get 1 over 3,000. This becomes, times, the natural log of p plus the natural log of 3,000 minus p. But be careful, there's a u substitution in here. So that really becomes a negative on the outside right there. And that's going to equal 1 over 1,000 t plus C1. Now don't forget the constant, that's C1, otherwise the AP won't give you any credit after this. And that's a lot of work we've done. I'm going to go ahead and multiply both sides by 3,000 just to make this look prettier. And I get the natural log of p minus the natural log of 3,000 minus p equal to 3t plus C2. Remember, C2 is just C1 times 3,000. Before I solve this, I'm going to use my log properties. I can't exponentiate yet. I'm going to use my log properties. This becomes the natural log of p over 3,000 minus p equal to 3t plus C2. Now again, call this log, don't call this ln. That's weird, okay? It's like calling sine sin, okay? We don't want to get in trouble by, by the thought police here, so please be careful how you say the words. Now, we're going to exponentiate. Now, when we exponentiate, remember, just e both sides. This just becomes the absolute value of p over 3,000 minus p equals, now, we know what's going to happen here. I know this is going to become C3e to the 3t, but we have to show that step. This becomes e to the 3t times e to the C2. That's my exponential rules from Algebra 1. If I'm multiplying the same bases, I can add their powers. We're just going backwards. Now, we let e to the C2 equal C3. Now we're allowed to do that. And I'm going to do two things. One, we get rid of my absolute value and change that around. So I'm going to get p net over 3,000 minus p equal to plus or minus C3 e to the 3t. And there's our answer right here. Now, we're not done yet, because what we have to do now is we have to find C3. This is a long process here. Now, they do tell us an initial condition. Remember, they told us 50 people initially had the flu. So, 0, 50. Now, if you notice, of the plus or minus, I'm going to use the positive, because that's a positive 50. So if I plug it in, I'm going to get 50, plugging it in, over 2950 equals to positive C3 e to the 0. So therefore, using a little bit of arithmetic, we get C3 equals 1 over 59. Plugging it in, I get P over 3,000 minus P, and watch how I'm going to write this. C3 is 1 over 59, so I'm going to write this as e to the 3t over 59. And now we have to solve for P. Solving for P, I'm going to cross multiply. We get 59P equals 3,000 e to the 3t minus e to the 3tp. Now, if you move this around, switch those around, look, you got Purdy. P e to the 3t, you got your exponential formula right there. It's kind of cool, huh? Yeah, look, Purdy again. See, Purdy. Purdy ugly. Moving on. So, bring this over, I'm going to get 59p plus e to the 3t times p equal to 3,000 e to the 3t. Factoring out the p and dividing, I'm going to get p equals 3,000 e to the 3t over 59 plus e to the 3t. And there's p of t right there. Whew. That took a long time. And on the AP test, 7 points on the free response question. All right, now let's do part B. You might be thinking to yourself, Mr. Wernow, part A took that long. Oh my gosh. You expect part B to be done in that spot? Yeah, I do. Because for part B it says use your solution in your graphing calculator to find the size of the population in 2 days. So basically it's what's P of 2 equal to. That I can just use a calculator for. Say hello to my yellow friend. Doc B, clear out everything. Alright, and I'm going to graph it. I'm always going to graph these. It actually makes it a little bit easier. Change this to a fraction, and I'm going to write this as 3,000. Whoa, not 30,000. 3,000 e to the 3x, divided by 59 plus e to the 3x. And I'm going to hit enter. There it is. And I want to find the value at 2. So I type in 2. I'm going to go menu, trace, graph trace. I'm going to type in x equals 2. Hit enter. Where's my value at? Oh, there it is. 2617.24. There it is. That's going to give me, so in 2 days, ready? 2,617.24 people are going to have the flu. But you're right. We can't have 0.2424 people. So the AP will accept 2617 or 2618. That's how many people have the flu in those 2 days. In 2 days. Now, for part C, for part C says, okay, now how long will it take for there to be 2,400 people to have the flu? So that's easy. We can take our P of T this time and set that equal to 2,400. Well, we already have that for Y1. Just plug that in for Y2. So I go to, messed up, tab. There we go, Y2. I'm just going to type in 2,400. Enter. Okay, and what I'm going to do is I'm going to find the intersection. I don't know, let's see if this will work without having to change my domain here. Analyze graph, intersection, enter. Enter. I guess I have to change my domain. So escape. So we got to change our domain. That's fine. Alright, edit window, window zoom, window. Okay, so take a look at my Y-min. I might go 0. I don't know. Enter. There it is. So unfortunately I do have to kind of change my window there a little bit. So menu. Now I'm going to go analyze graph, intersection, upper bound. Oops. How would I do this? Menu, 6, 4, lower bound. I'm scroll it over a little bit. Hit enter. Upper bound. Scroll, hit enter, and it gives me 1.821 days. So T equals 1.821 days. Very easy. Alright, so hope you had fun with this. I know I did. And I'll see you guys later. Bye-bye.